Welcome to episode 2 of the Statistics and Probability series. In this episode, we'll learn the core rules of probability, the addition rule, the multiplication rule, and the law of total probability. Let's begin. The addition rule helps us find the probability that at least one of two events occurs. If A and B are two events, then the probability of A or B is the probability of A plus the probability of B, minus the probability of both A and B happening. Mathematically, this is stated as P of A or B equals P of A plus P of B, minus P of A and B. Let's try an example. The probability that a student passes math is 0.7. The probability that they pass English is 0.6. The probability they pass both is 0.5. What is the probability the student passes at least one subject? Using the addition rule, we get 0.7 plus 0.6 minus 0.5, which equals 0.8. If A and B cannot both happen, they are disjoint. For disjoint events, the intersection is 0. So the formula becomes P of A or B equals P of A plus P of B. Example. You draw a card. Let event A be drawing a heart. Let event B be drawing a spade. Since a card can't be both, they're disjoint. P of A or B equals 13 out of 52 plus 13 out of 52, which is 26 out of 52, or 1/2. The multiplication rule finds the probability that both events occur. If A and B are independent, then P of A and B equals P of A times P of B. If A and B are dependent, then P of A and B equals P of A times P of B given A. Example. A coin is flipped, and a die is rolled. Let A be the event of getting heads. Let B be the event of rolling A4. These are independent events. P of A is 1/2. P of B is 1 out of 6. So P of A and B is 1/2 times 1/6, which equals 1/12. Let's try a dependent case. A box has 5 red and 5 blue balls. 2 balls are drawn without replacement. What is the probability that both are red? The probability the first ball is red is 5 out of 10. After removing one red ball, there are 4 red left out of 9. So the total probability is 5/10 times 4/9, which equals 20 over 90, or 2/9. The law of total probability helps when an event depends on several other disjoint events. If B1, B2, to Bn form a partition of the sample space, then the probability of A is the sum of the probabilities of a given each Bi times the probability of Bi. A factory has 2 machines. Machine A produces 60% of the items. Machine B produces 40%. 1% of items from machine A are defective. 2% from machine B are defective. What's the probability that a randomly selected item is defective? We compute 0.6 times 0.01 plus 0.4 times 0.02. That's 0.006 plus 0.008, which equals 0.014, or 1.4%. Let's summarize. The addition rule handles the probability of A or B. The multiplication rule handles A and B, with attention to independence. And the law of total probability handles complex conditional cases where an event depends on multiple scenarios. In episode 3, we'll dive into conditional probability and independence. See you in the next episode.